Hello, today I want to show you about my experiment. So in my previous video, I already tell you about I want to make a AI browser game. What the meaning of this? It's like, you know, in the browser you create a game and then instead of you playing that game, I want to create that AI that playing that game, and this AI will try to learn by itself how to play that game. And then the game that I want to that AI play is snake game. This is a simple snake game. And as you can see here, I already found the gym snake game environment because in the gymnasium module there's no environment for the snake game. What available is like this. There are acrobot, card pole, pendulum, mountain car, and then in here there are scar racing, and there's N, hopper, and etc. And from all of this list I can find the snake game. So that's why I searched in the GitHub and I found this. I will put the link of this GitHub in the description of this video. Okay, let's see how about in the environment. Oh yeah, actually this video should be the part 1 of the video, but because I must modify, I can say a major modify of this Gym Snake game environment. That's why it will be take a long time, and to export the model from the torch to ONNX, I think it's more easier. That's why I create that video first, and then will be the second video. Okay, what we must concern, I think there's two functions that we must concern. That is reset function and step function. The reset function is when we reset the environment to the initial condition, right? So as you can see here, the script is initiate the board, and here it initiate the snake, and as you can see here, the long of the snake is 3 units. And then here, this is where the part where put the snake body to the board, and then this is where we get the observation. Observation is the will be the input for our model, and here the info is just additional information. And as you can see here, the observation is same as get ops. Let's see what is get ops. Here, so this get ops is same as, so it's change the type of the board, and the board is looks like a two-dimensional array that the size is depend on the variable size. And here when you initiate the snake game environment, you must define the size, and the default is 15. And as you know, in my environment, in my script, I set this as 25. So our input of the model, if we using this original script, it will be 25 times 25. And because we're using autocritic, and this autocritic is actually a multi-layer perceptron, we must flatten the data, right? So it must be 25 times 25. So the input size will be 625. And then let's move on to the step. And in the step, as you can see, this is the function that will be called when we inputted the action that we got from the model. That is, in this case, is actor critic and PPO, right? And as you can see here, this is where we update that. And that what I want to highlight is here. So the moment that we can get reward and punishment is when the snake is out of the board or it crashed with the boundary, and then if it hit the tail in here, so the reward will be -1. I can say this is punishment. The punishment will be -1 if he outside the board or crash the boundary. And then in here, if he hit nothing or he just plain move, the reward will be 0, so there will be no reward. But if the snake is hit the hit the food or the target, and then it will be a reward as 1. And then after that, yeah, it's return the observation, the reward, the this is the status that state that if this game is end or not. And then this is I think this is just additional information. And for me, I think the problem in this script is here. When the snake is hit nothing, it just plain move, there's no reward or punishment. And I think if the environment or the grid is big, this will be the problem. I think this will make the model will be hard to convert. That's why I will show you the modification that I do in my modified snake game. So here, first let's do the reset. And first I want to show you this. So as you know, in the original script, the observation is the grid of the snake game, right? So it will be shown all the grid and the snake and the target. But as you can see here, the input will be too big. Then I already test if I not change this observation, if I'm using this all of the grid in my experiment, it will be not convert. And then that's why I do the feature engineering. So I will not show all the grid. What I show is the target of the the location of the foot, the coordinate x and y, and then here this is the distance of the head. So here, for example, this is the snake. So when the snake is moved to the right, the distance to the left, it will be 1 unit. So for example here, we'll show you just like this. For example here, this is the snake head. So the distance for the left will be 1 because here this is the tail snake, right? But for the distance in the up, for example, this is the location is for the head, the location will be 12.12. Yeah, I'm sorry because I write this using mouse, so it's messy. So the distance for the up direction, it will be 25. subtract with the 12, it will be 13, right? So the up will be 13. This is will be 0. No, not 0. This is will be 1. And for down, it will be 12. Yes, 12. And for the right side, it will be 13, right? And yeah, in the left side is 1, the right side 13, up 13, below or down is 12. So we will have 8 value for the observation. That is, first we will have the location for the we will have the location for the snake head, and then we will have the distance that I already explained previously, and then we will get the location of the target, and then yeah, we return that. Oh yeah, I forgot to mention this. So before we return this observation, we will normalize, because the value of the the target location for X and Y, it depend on the size, the scale. Yeah, the scale for this value will be depend on the size. That's why we normalize using the size, the variable size. So in my case, because I am using 25, it will be divided by 25. And then we change the type, because the gymnasium environment 1 the type as float 32. That's why I change this to the float 32. Okay, now let's move on to the step. This is the step. So the problem with this is my opinion, the problem with the original script is when the snake is want to approach the foot, because because the distance between snake and the foot will be not 1 unit. So whatever the move that the snake that have to take, whether it's approaching or not, the snake will be not get reward or punishment, right? But when it approach the foot, it shall get the reward. So it will be signaling the model that it's a good move, so it must continue. But if we don't inform about that, I think the model will be confused, and that's why in my opinion, it will be hard to convert. So as you can see here I have a mini reward, and mini reward is the comparison from the new distance and the old distance. So if the new distance is smaller than old distance, so it's mean the snake is approaching the foot, then the reward will be here 0.1, but otherwise it will be minus 0.1. And this mini reward will be added to the all condition, same with the original script. So in the case of it just approaching the foot and the snake is hit nothing, it will be just mini reward, as you can see here. And the rest is same with the reset. I think here I get the observation, and then here I normalize, and then I return all of that. Okay, this is snake game. And for the script of PPO, this is the same script that I'm using in my previous video, because of my finding in my previous video that I state that in my experiment that when we ignore the entropy, it will be improve the performance. That's why in here I just ignore the entropy, or I just remove the entropy. The rest is the same. And here this is the build model script, and I think this is same. The difference is I import here the custom gym snake game, because this environment is not available in the original gymnasium. and yeah, the rest is same. Actually I can run that model in here, but because the running time will be in of this model will be 1 hour, so yeah, I can show you in here. It will be too long for the recording of this video. So here we just run this, and then we will get same with the my old video, my previous video. We will get here the model that we will convert to ONNX later, and then here we also get the logs, and the logs that I have is here. Okay, let's see how the reward in this training of this model. And as you can see here, I think the pattern is same as my previous experiment, and as you can see, the fluctuation of the reward is quite high. That's why I recommended that you using a early stop section in here like this. And as you can see, the threshold score in here, you must set this, but in this experiment I still don't know what the score that we must set in here. That's why I recommend that before you run or before you train the actual model, you must run it fully. So in the first run we will get the statistic from this of the performance like this. This is the average. Let's see about the maximum. The maximum is 30. Let's see the standard deviation. It fluctuates with 5, so the range of this, because this is the mean, I think the range will be from 16 to the 26. Yeah, from 16 to 26. If you want to quick convert, then you must set it as, I think it will be 25, I think. If you set just like in my previous video as 100, because the environment is different, this threshold score will be not met. So in this case we must set it as 25. Or if you want to it be more perfect, maybe you want to try as 29, or something else. Oh yeah, I forgot to show you how this model works. So here, this is the result of the training. Oh yeah, for that I will show you the test model script. And here I think the test model script is generally or overall it's same with my previous video, but the difference is the environment is different, of course, and then the checkpoint path or the model file that I use is different. Okay, let's run this. Here, and as you can see here, the AI understand how to play this game, right? Yeah, something like that. And I think this is enough. I think I satisfied with the performance of the model, and that's why in the part 3 I will finish the project and we will build the game in the browser or in the HTML code. Okay, see you in the next part. Bye.